Hello everyone, today I want to show you one interesting project how you can use Discord bot on ESP32 to make nothing less but RFID attendance system, which is, believe it or not, very efficient, so stay with me after the intro. Okay, welcome back. In previous video we have saw what is the Discord, how to use ESP Discord library and how to create Discord bot. So I will skip that parts in this video. Before we start with project setup, I want to talk a little bit about architecture behind the scenes and how everything works. What we know from the last video is that the Discord provides us free communication layer via reliable WebSocket channels with other users or bots. That fact will be the foundation of this project. On one side of communication is Discord bot living in the ESP32 device, which has attached MFRC522 RFID module. On every detected RFID tag, ESP32 will serialize tag into appropriate package, and by using Discord bot, send that package to the Discord server into specific channel. This seems straightforward, but obviously this is not enough because Discord server needs to process package and tell us to which employee tag belongs. Well, that is true, and that is exactly the reason why we have the second side of communication. Here we have WinForms desktop application written in C#, which as well have one Discord bot inside of self, and this bot is a member of the same Discord server as well as the first one. Next question is why we need two bots? Well, it's simple. First one in the ESP32 is a producer of RFID packages, and this second one is consumer of that packages. And package is nothing else but custom formatted Discord message. For the sake of the project terminology, we will call first bot as the slave bot, and he is packages producer. Project is designed in a way that we can have multiple slave bots. For example, if company which implements this system want to have RFID scanners on multiple entrances. By following analogy, this one is a master bot. Master is only one by project instance, and he is the consumer of packages produced by slave bots. In this video, I will have only one slave bot, and that will be the same bot created in my previous video. For distinction between master and slave bots, project used Discord server roles with corresponding names. Master has assigned master role and slaves have assigned slave roles. All necessary roles as well as communication channel will be automatically created by this WinForms application. For every this created action, application will ask for the permission, so nothing will be created on Discord server if a user of the app does not approve that. So, when the one of the slave bots sends a package to the Discord server, Discord will broadcast that package to the master bot. When the master receives a package, multiple security checks will be applied, like if the sender of the package is a bot. Does it has a slave role? Does the received message really represent a RFID package? etc. One extra layer of security is that the channel in which all communication takes place is visible only for master and slave roles, and of course to administrators of particular Discord server. When all security checks successfully passed, RFID tag serial number will be extracted from the received package and is going to be checked to which employee does it belongs. When correct employee is obtained from the database by serial number of the tag, appropriate activity will be recorded back into the database, like if employee has just arrived or whether he is going out. It's interesting to mention that the one employee can have multiple assigned RFID tags. Okay, let's switch now to implementation. Here is a GitHub repository of this project. Project is separated into two folders. First is Discord RFID folder and represents a WinForms application written in C# using .NET framework. Second one is ESP folder and it is application for ESP32 written in C using ESP-IDF framework. If you are interested, down here is a nice abstract illustration of project, as well as short sections about what actually is and how this project works. A little down further, you can find the tool stack I have used for project realization. For ESP32, I have used ESP-IDF, as well as components like ESP Discord for creating a slave bot ESP-IDF RC522 for communication with the RFID module, and base64 library for encoding packages into appropriate base64 messages. While in C# I have used NuGet packages like Discord.net for making masterbot, SQLite as database for storing employees and other domain models, Serilog for logging application events, and JSON.NET package for the serialization of JSON strings. Let's start with WinForms App. There is two ways how you can get app running on your PC. First is to clone this repository on your PC, go inside of Discord RFID folder and build solution with Visual Studio by yourself. Second and easier way is to go here in releases of repository and download the application down here. That is exactly what I'm going to do. After downloading and extracting the zip file, I'm here in application folder. Click on Discord RFID.exe to start the app. On the first start, application will ask for the authentication token of masterbot. I repeat, master, not slavebot. Beside that, we can see that application has automatically created RFID.db as SQLite database, config.json as project configuration file, and log folder for saving application logs. Okay, we need the token of masterbot, but before that we need to create one. So open discord.com/developers. Here under the applications I already have one, which I have created in my previous video. That application contains the bot from previous video, and that bot will be used now as a slave bot for this project. Okay, let's create new application for masterbot. Steps are the same as in the last video, so I will do it this time without voiceover. Okay, once when we have added bot to our server, copy the token and paste it to application. Next steps are straightforward. First, bot will ask for permission to create master and slave roles on your Discord server. Now, bot is asking for permission to create channel for communication with slaves. Click yes and masterbot is ready. If I go now to my server, I can see that RFIDX channel has been created and it is marked as a private chat visible only to master and slave roles, as well as for roles which has administration permissions in my server. If you take a look on this members list, you can notice that there is no our bot from the last video. That is because that bot does not have slave role in order to be able to see this channel. So let's go quickly to channel chat, and now bot is here. Click on bot and assign him a slave role. RFID-S is a slave role, and this one with M at the end is a role for the master. If you remember, these roles are generated automatically by our application. Application seems pretty empty. That is perfectly fine for now because there is no registered employees or any activity in database. Leave this application as it is for now and let's switch to application for ESP32. For the purpose of building ESP-IDF application, I am using Ubuntu 20.04, which is running on WSL2 platform. Video about setup WSL2 for ESP-IDF is on my channel. With git clone command, I will clone the project repository. After cloning, with command cd discord RFID, go inside of repo, and again with cd esp, go inside of ESP-IDF project. With next command, generate certificates for slavebot. Set target to ESP32 with command idf.py set target ESP32. Open configuration menu with idf.py menu config. In example connection configuration, set your wireless network credentials. Go back and enter Discord RFID item. Here you can see required pinout for MFRC522 module, or if you want you can change it. This pinout looks okay for me, so take ESP32 and RFID module. Connect MISO of RFID module to pin 25 of ESP32. MOSI goes to pin 23. Clock to pin 19. And data pin goes to pin 22 of ESP32. Ground of RFID goes to ground of ESP, and 3.3 of RFID goes to 3.3 of ESP. Leave other configurations as it is and go back. Last one configuration is slavebot token. Go into component config and all the way down to Discord item. Open Discord developers and take the token of slavebot. Paste the token to configuration, save configuration with key S, and with escape key leave the configuration. Connect ESP to your PC and we can execute next command for flashing and monitoring application. If you are not familiar with this IDFX command, that is command which giving us ability to flash applications into ESP32 because WSL2 natively does not support USB devices. More about this command you can find on my channel in video about ESP-IDF on WSL2. Okay, we can see that application has been boot up and here is a message that everything is initialized and ESP now listen for RFID tags. So bring up the WinForms application and let's apply some RFID card. Basically, in the same moment when we have applied RFID card, we can see that new package has been arrived. Type of the package is tag and this number indicates the serial number of card. Number is in orange color because no one of employees in database has assigned particularly this tag. Actually, we don't have any employees in database, so let's create new one. Click on employees and then on the button new. Enter desired informations and click save. Click close and now we can see some nice counters which says how much employees are present in company and how much are absent. Employee is in database and now we need to assign this tag to them. How we can do that? There are two ways. First one is to go again to employees, then on RFID tags and manually add new RFID tag with serial number. But there is easier way. What we can do is simply right-click on received package and click on attach tag to employee. Choose desired employee and click save. Tag is now recognized as a tag which is assigned to existing employee and now activity has been recorded in database. This activity says that employee with this tag has arrived in company on this time. Apply the same card again. Now activity says that employee has left the company and here is information at which time the activity has been recorded and how much employee was present in company. Application is pretty reactive, which means that as activities are recorded, counters of present employees are refreshed automatically. If we take a look now on Discord channel, where all communications takes place, we can see how actually packages looks alike. They are not human readable, but it's nothing super secret. This is base 64 encoded string, which after decoding produces human readable JSON package where is informations about RFID tag serial number, as well as infos about ESP32 like version, uptime and available memory. For the end, let's create new employee which will have two different tags. Okay, when we have new employee, apply some different card to RFID module. Attach this tag to new employee. Again, apply another tag and attach it to the same employee as well. Now we can use one tag to came in and another one to came out. In the list of activities, we can see exactly with which tag employee has came in and with which tag he left out. Okay guys, I hope you will find this video useful or at least interesting. If you do, you can write some comments down below, leave a like or support me with a subscribe. Anyway, thank you for watching and till the next time, see ya!